Okay, let's work problem 1 on page 20 of the student packet. So we're looking here at a position versus time graph. And the first question is, where is the object moving at the slowest speed? So to find something that's moving at a slow speed, you want to look for a tangent that is horizontal. And as I follow this curve, the first place I find where the tangent to the curve would be horizontal is at point B. What we see happening here is that the object is going in the positive direction but slowing down as it moves from A to B. I can tell it's slowing down because the slope starts out steeply positive and then moves to horizontal. Then it moves in the negative direction for a while, and as it gets down, at first it speeds up and then it slows down in the negative direction. And when it reaches D, there's another point where the tangent line would be horizontal. So at both B and D, the velocity for just an instant would be equal to 0. So B and D are the 2 points we're looking for, because you look for a horizontal tangent, place where the tangent line would be horizontal. Then it asks in part B, in what range is the velocity positive? Well, we look for where it's moving in a positive direction, because remember, the sign of the velocity has to equal the direction that the thing is moving. So the places where it's moving in a positive direction are from points in the range from A to B. See, it's going from position 0 to position 50 as it moves from A to B, so it's moving in the positive direction. And then there's another range, which would be from D to F. That's another range where the position is increasing. It starts there at 20 meters at D, and it moves up to maybe 57 meters at point F. Okay? Part C says, in what range is the velocity negative? So I look for something that's moving in a negative direction. And the only range I see where the object here is moving in a negative direction is from point B to point D. There it's moving from a position of 50 back to a position of 20. It's moving to smaller positions, so it's moving in the negative direction. D and E are asking about where the acceleration is positive or negative. So there are two scenarios for each of these. In part D, we're looking for where the acceleration is positive. There are two possibilities. One is that it's speeding up in the positive direction. In that scenario, the velocity would be pointing in the positive direction and the acceleration would be pointing in the positive direction. It would be speeding up. The place on this graph where I see something speeding up in the positive direction is from D to E. Because at D, the slope is horizontal, and at E, the slope is a steeper positive slope, so it's speeding up there. The other possibility where acceleration would be positive is if it's slowing down in the negative direction. And on this graph, so I'm looking for something moving in the negative direction with the slope starting steeper and getting less steep. And the only range where I see the slopes getting less steep in the negative direction is from C to D. Okay, question E is asking, in what ranges is acceleration negative? So here I want to look for slowing down in the positive direction, and the place on this graph where that's happening is in the range from A to B, because the object is starting out moving in the positive direction at a rapid velocity. I can tell that because the slope right at A is a steep positive slope, and by the time it gets to B, the slope is 0, so it is slowing down from A to B while it is moving in the positive direction. That means that acceleration is negative. The other scenario would be for something that speeds up while it's going in the negative direction. So I'm looking for a scenario where the slope of the position versus time is becoming steeper, but in a steeper negative slope. And that is happening in the range from B to C. The next question asks, in what range is acceleration 0? Acceleration equals 0 means that there is no change in the velocity. The velocity is constant. And that means that for every additional second, the position is changing by the same amount. So that means that the position versus time graph is linear. The only place on the graph that we're currently looking at where I see position being linear is here from E to F. In that position, in that range, E to F, the graph is linear, and that means that position is changing at a constant rate and the velocity is constant. That means acceleration is 0. The last question here asks, what is the average velocity for the 3 seconds of data that we have? Well, average velocity is the displacement over time. And displacement is the final position minus the initial position. So we only care about where it started and where it ended, and then we divide that displacement by the amount of time that it takes to make it move that far. So our final position up here is at F. So our final position, I'm going to have to estimate because it's between 50 and 60. I'm going to call that 57 meters. And our initial position is here at A. That was at 0 meters. So our displacement is 57, that's the final position, minus 0. The time that it took to move that far was 3 seconds, and so the average velocity is 19 meters per second. Okay, thank you.